Here's a simple example of a Kirchhoff loop rule. I've got a circuit with just a battery and a resistor. There's only one loop. You name the current I1 by picking a direction that you're saying it's flowing. And then you need to choose a direction that you're going to go around calculating. That's not the same as the direction of the current. You choose a loop, well there's only one. You choose a place to start, it doesn't matter where. And you choose a direction. Now suppose I just start here and say I'm going to go clockwise. What does Kirchhoff's loop rule tell us? The first thing we encounter is a battery. We are going in the negative end and out the positive end, which is the correct way to go through for current to go through a battery, which means we get a positive 6 volts. We then move along, and the next thing we encounter is a resistor. Now, a resistor doesn't have a plus or minus end. The way you tell plus or minus with a resistor is you look at which way the current is going compared to which way you're going. If you're going with the current, you're sort of going downstream the usual way. A resistor consumes voltage, so that would be minus IR, minus I1 times 100 ohms. And then we keep going and we're back where we started. And since voltage is a property of a location, if you go through a complete loop, you're back where you started. Your total change in voltage has to be 0. That's Kirchhoff's loop rule. When I'm solving a system of these, I always divide by the biggest common number and the ohms unit. It seems kind of ridiculously belabored for such a small circuit, but this is positive 3 amps minus I1 times 50 equals 0, which is a simpler equation to solve, which is important if you're doing several equations. All right, but what if we had gone the other way? What if I'd said, okay, I'm going to start here and I'm going to go counterclockwise? Well, if we're going counterclockwise, I go along this way, and the first thing I encounter is a resistor, but I'm going upstream. I'm kind of fighting the current here. So that's actually a plus IR, plus I1 100 ohms. And we continue, and then we hit a battery and we're going in the positive end. We're going in the battery backwards. So that ends up being a minus 6 volts. And then we're back where we started, and it equals 0. This is exactly the same equation multiplied by -1, so it has exactly the same answer. So no harm done. What if I start in a different position? Totally doesn't matter. If I go one way or go the other way, I'm going to get the exact same terms in a different order. It just doesn't matter where you put your starting point or which direction you do your loop. And it doesn't even matter which way the currents are, so long as you're consistent. Choosing the currents is like choosing a coordinate system. And then you have all that flexibility. If you're feeling indecisive, here's a rule. Pick your loop, go to the bottom left corner, and go clockwise. That is completely arbitrary, and it will always work. I hope that makes it clear how much flexibility you have in doing a simple Kirchhoff loop rule.